Hello everyone, welcome to my channel. My name is KenMath, and if you are new to my channel, please don't forget to subscribe and hit the notification bell so that every time when I post a new content, you'll be alerted first. Okay, so in this video, we are going to talk about product rule. That is what we're going to talk about. Product rule. So we are still on calculus, so we are going to talk about product rule. We did the power rule some time back. So in the previous video, if you go and check in the previous video, we did the power rule. Okay, so in this product rule, the things that we're going to talk about how to differentiate using the product rule. Find the dy over dx. So dy over dx over, for example, we have been given y is equal to, open bracket, we have x squared plus 1 close bracket, and then again open bracket, we have got x cubed, and then plus x plus 5. So we have got something like this, and then they have said differentiate with respect to x. So something like this. So we are differentiating this. We have got one function multiplied by the other function. So one function multiplied by the other function. So they are multiplying this function times the other function. That's what it is. So when you're multiplying this function multiplied by the other function, what we do is that we use what we call the product rule, which states that if we are finding the dy, I'll put this side the rule. So if you're finding the dy, or if you are differentiating or finding the derivative of v, we are multiplying these two functions. So v is a function and another function. Then what we're supposed to do is to find. So this is what we're supposed to. So when you're finding the derivative of functions which are multiplied, then get the first function the same way it is, and then find the derivative of the second function, and then plus get the second function the way it is, and then find the derivative of the first function. This is what is written. So this is the rule which is there. So we have got this function which we are going to name as a v function, and then we have got this other function which we are going to name as u function. Now how can we solve something like this? So what we're supposed to do is that we're going to get, for example, we're going to say the dy over dx. So dy over dx, over we said it's of v multiplied by u. So v multiplied by u. So dy over dx multiplied by v multiplied by u. So we're going to get the same function, the function which is the first one, the same way it is, which is x square plus 1, the same way it is. And then we're going to multiply it with the second function. So the second function will find the derivative of the second function. And we have seen that this second function is the power rule we are going to use. So the power rule states that this 3 is going to be in front, so we say 3x, and then from 3 we take away 1, which will give us to the power 2, and then plus the derivative of x, a single x is 1, so we're going to have 1 there, we close. And then this is the derivative of the second, the dy over dx of the second function. And we're going to say there is plus here, so plus, we get the second function the same way it is, which is x to the power 3 plus x plus 5. So x to the power 3 plus x plus 5, that is the other function. And then we're going to multiply by the dy over dx of we differentiate this second function. So when you differentiate second function, it's the same as 2x there, the second function, and then we close, because the dy over dx of the constant number is 0. So we can end it from here, or we can go further from here. So we can expand them. So we can say x square multiplied by 3x square, it will give us 3x to the power 4, and then x square multiplied by 1, it will give us plus, which is x square, and then 1 multiplied by, we distribute 1 multiplied by 3x square, it will give us plus 3x square, and then plus 1 multiplied by 1, it will give us 1. Okay, then we come to this side, we distribute the same way. So plus 3x to the power 3 multiplied by 2x, it will give us 2x to the power 4, and then x multiplied by 2x, it will give us plus 2x to the power 2 and then plus 5 multiplied by 2x, it will give us plus, which is 10x. So 10x. So we have expanded it, and after we have expanded it, we group the items. So we're going to group the items. So I will say this one and this one and this one, they are items, and also we're going to say this one and this one, they are items. So we're going to start with those ones. So we're going to say equals 3x to the power 4 plus 2x to the power 4. We add the coefficient, so it's same as 5x to the power 4. So 5x to the power 4, and then plus, which is x square plus 3x square plus 2x square. So these are items as well. So we're going to say the coefficient of x plus 3 is 4, because there is a coefficient of 1 here. 1 plus 3 is 4, plus 2, it gives us 6. So say 6x to the power 2, and then plus the other one, which is remaining. So it is 10x. That is the one which is remaining there. So this is the final answer. This is how we find using the product. This is how we do it using the product rule. So that is how we do it using the product rule. So that's the answer. We're going to the next example. So sometimes you find that you can expand this and then find use the power the power rule to find the dy over dx of each term. So it will still give you the same answer. So that's what we usually do. So this is how we use the product rule. The other example on the product rule, we've got y is equal to 2x plus 1 close bracket, and then open bracket x plus 1 and then close brackets. So they have said find the dy over dx of this one. We're going to use the same one, which is the product rule. We're going to use the same product rule, and then this is what we're supposed to do, which is the dy over dx of these two functions which are multiplied. First of all, get the function, which is the first function, and then differentiate the second function, and then you get the second function the same way it is, and then you differentiate the first function. This is what we do. So we are going to name these functions. First, we are going to name these functions, and this one is our v, and this one is our u. Those are the functions that we have. And then for you to do that, we're going to say the dy over the dx, this is d, sorry, over the dx, this is x, of the function, which is v, multiplied by the second function, which is u, and then we close. So this is what we have. So we're going to say it's equal to the function the same way it is, because they have said we have to get the function, which is function v, the same way it is. So we're going to say it's 2x plus 1, and then we close, and then we multiply by the derivative or the dy over dx of the second function. So the dy over dx of the second function is the same as 1, because the function, the dy over dx of this x is 1, the dy over dx of 0, of a constant number is 0, so it's same as 1, take away 0, it's 1. And then we add, they have said add, and then we get the second function. So the second function, the same way it is, which is x minus 1, and then we close, and then we get the first function. We differentiate the first function. So when we differentiate the first function, it's the same as it will give us 2. So the dy over dx of 2x is the same as 2, plus the dy over dx of the constant number is 0. So 2 plus 0, it is 2. Then from there, we can expand it. So 2x multiplied by 1, it's 2x, and then 1 multiplied by 1, it will give us plus 1. And then we add, which is x multiplied by 2, which is 2x, and then for negative 1 multiplied by 2, it is negative 2. And then we group the like terms. So we can say this and this, they are like terms, and also we have got this 2x and 2x, they are like terms. So we're going to add. So for these two, we're going to add, so 2x, so we're going to say 2x plus 2x, it will give us 4x, positive 1 plus, which is negative 1. That is how we do it. So that's how we use the product rule. If you are new to my channel, please don't forget to subscribe and hit the notification bell, so that every time when I post a new video, you'll be added first. Thank you very much.